And we also have from Dar es Salaam, the University of Dar es Salaam, represented by Dr. Professor Biori, Hannibal Biori, who has also a number of colleagues with him as well. And we also would like to acknowledge the support from the Volvo Research and Education Foundation, which supported this work. So I will be focusing on these two cities, Kumasi in Ghana and then Dar es Salaam in Tanzania. And the question is about transport access in urban areas. Right, so in terms of transport access, which I'm simply referring to here as access. Oh, sorry. Looks like. Okay. Okay, please go back, please. All right, thank you. All right, so in terms of transport access here, transport access in urban cities is a welfare and a livelihood issue in the sense that the access for people to be able to have access to a transport, either motorized or unmotorized, and as a means to be able to access either health, education, school, or healthcare, and other forms of livelihood challenges is a challenge in most urban cities in Sub-Saharan Africa. And in most of the urban cities, what we also realize is that this accessibility can be differentiated. In other words, it can be unequal in different parts of the city. And there are several drivers that will drive this unequal accessibility. Some of these could be in terms of capacity. Some of it could be in terms of transport infrastructure that is available or unavailable in some of the areas of our city. The lack of transport access or transport infrastructure in some of these parts of our city can also lead to what we call mobility-related social exclusion, in the sense that in cases where people do not have access to transports, either motorized or they have limited transport infrastructure, their access to either school for education or healthcare can be limited, and therefore they could be excluded in some of these activities. Transport access is also very important in allowing to access socioeconomic, for instance, workplace, healthcare, and all of those other opportunities that are very important for our livelihood. Okay, next. So, trying to evaluate or assess transport access is very important because it gives an indicator of the welfare of a particular community. So trying to measure access is actually a challenge because there are so many drivers that we need to consider. But trying to understand how it is measured will also give us a better understanding as to how different populations within our community, be it low-income populations or middle-income populations, are able to access these various socioeconomic activities. And being also able to measure it will give us a way to be able to devise ways to better mitigate some of these drivers, and also be able to assess the performance of some of our road infrastructure that we have developed to be able to facilitate accessibility purposes. Okay. So in what we refer to as the informal urban communities, these are usually communities that have limited, for instance, land rights or limited social amenities, limited transport infrastructure. And in Sub-Saharan Africa, this constitutes about 72% of our urban landscape, and that is a huge part of most of our urban or for our cities in Sub-Saharan Africa. And like us also acknowledged earlier, they are limited. They also have limited facilities. Road construction may not be well maintained in those areas, or they may not have transport means. They might rely on non-motorized transport to be able to access some of these facilities as well. So they are limited in terms of addressing or mitigating some of these access issues. So the challenge that we intend to address in this project was, how do informal urban communities perceive, experience, and use transport in their daily activities? And by this, we are not only looking at how we have provided road facilities and transport facilities, but we also want to know how users also perceive how they undertake those daily activities as well. And we restate this or reframe the research question in terms of the extent to which that potential is achieved as an indicator of the performance of the transport system. Okay. All right, so to be able to do this measurement, we looked at two key measures. One is in terms of what we refer to as objective accessibility, and by this, what we are saying is that once we are able to provide a transport infrastructure and provide vehicles and all of that, either motorized or non-motorized, how does this facilitate people in reaching, for instance, a workplace, a healthcare place, or school, or market, and things like that? So that will be the objective accessibility, and this will be simply defined by the quality of the road network there, the mode of transport that has been used, and all of that. But then we also look at the perceived accessibility, which is the case, how do users actually experience it? So in this case, the perceived accessibility is a way of actually assessing how our transport facility or infrastructure is actually performing. How is it helping people to be able to access a workplace, a healthcare, a marketplace, a school, and all of those areas? So these are the two major aspects of accessibility that we looked at, so that we can use it to assess transport infrastructure in general. So to do this, we've looked at a number of socioeconomic and cultural opportunities, one in terms of a workplace, a healthcare, shopping or markets, the extent to which people can also access a school, place of worship, and family and friends. Now, the reason why we segregated quite a number of some of these basic needs is that sometimes people may participate in one or two of this. For instance, if you are unemployed, you may not be able to travel to work. Or if you are not going to school, or you finish school, you may not be able to, answer that part of the question. So we've got quite a range of these accessibility areas, so that we can get a broad range of how people actually undertake these or experience in accessing these opportunities. All right, so to do this, this is some of the study communities we have shown in this map. So here we are simply showing the map of Ghana, and Kumasi is around in the middle of the country. And within Kumasi, we have selected a number of communities which we consider to be informal urban communities within the city. And Kumasi is second largest city in Ghana, and it's a very sprawling city, has a very high population density, and there are quite a number of informal communities that there are several high density of buildings that really also impact on how people access different opportunities. The second city is the city of Dar es Salaam in Tanzania. So in Dar es Salaam, we have also selected a number of communities in Dar es Salaam. Dar es Salaam is a much bigger city compared to Kumasi, and so we have selected quite a number of them. And Dar es Salaam has a higher population density compared to Kumasi, but there are also similar transport modes in terms of paratransits, motorbike taxis, and tricycles, which are also used in both cities. So that is also a basis for comparing these two cities. So in selecting the various stakeholders, we have listed quite a number of them here. I will not be going through all of them, but in general, what we had is we have a section of transport agencies in terms of, for instance, urban roads, rural road agencies, transport providers, paratransit authorities, driver operators, paratransit operators, and then we also have community leaders who we have also consulted local councils within these two cities. So this slide is simply showing a range of the stakeholders which we have listed in the two cities. So we have conducted two stakeholder workshops for the various stakeholders I've listed in the previous slide. And this was the first, this was the stakeholder consultation we've conducted in Ghana, in Kumasi. And we have, as I said, we have brought together quite a range, diverse stakeholders from transport agencies, transport users, also persons with disability were also invited as well to give their perspective on transport access in the two cities. And the second workshop we organized is in the city of Dar es Salaam, specifically at the University of Dar es Salaam. This photograph also shows some of the stakeholders who were present for the workshop at Dar es Salaam as well. So to engage the stakeholders, we were able to make sure that the range of questions that we posed to them or interrogated with them are very similar. So these are some of the themes that we focus on. For instance, we looked at the range of the stakeholder backgrounds and goals. What are their responsibilities in the various communities that we studied? And then we also looked at their view of accessibility. What is some of their roles they play in there? What are some of how did they perceive accessibility in those communities? What are some of the solutions they see there? What are some of the challenges they've seen there? So that is also another aspect where we focus on. And we also asked them about their related stakeholders who help them in undertaking or mitigating accessibility in those two communities. Then we also looked at whether they have the right performance goals and organizational structure, institutional structure, to enable them to undertake their role in those communities as well. And we also looked at whether they have the right tools, whether they are well equipped to undertake those accessibility challenges in the communities. And we also assessed their skill level in terms of capacity development for the various stakeholder agencies as well. So these are a range of themes that we've focused on in our stakeholder engagements. Okay. So I would like to share with you some of the findings that we got from our stakeholder engagement with this. And as you see here, in terms of the range of stakeholders that we have from Ghana, for instance, we have grouped them into managerial position, operational position, and technical or advisory positions. So what we are seeing here is that we have the stakeholders who avail themselves, they were from a range of positions. So from managerial positions to technical positions and operational positions as well. And there are very similar proportions in terms of what we got from Ghana and then also from Dar es Salaam in Tanzania as well. Just that in Tanzania we added a supervisory position as an additional category as well. Next, we also looked at what are the similarities of questions in terms of the stakeholder activities that they undertake within the community. So we ask them if access in the community, access to school, access to market, access to school education, if those access issues are addressed, how will they help them in their work? So we have questions, some of their responses or some of their findings relate to, for instance, questions about reduced transport time. There's questions about less crime incidences. There are also responses about fast mobility, also promote safety. There are also questions about reduced maintenance costs or operational costs in both Ghana and Tanzania. Next, we also have a question in terms of which of the accessibility, the stakeholder activities which of the stakeholder activities facilitate accessibility in the communities. The stakeholders engage in a whole range of activities, but we wanted to know which of the specific ones they undertake to be able to help locals or the local residents in assessing some of these economic opportunities. And some of the things that were listed, for instance, we have things about offering transport services, construction of roads, and social amenities. There were common things about also land use planning, settlement planning, road maintenance activities are some of the leading stakeholder activities that have been listed in the two cities to be common for them. And then there's also a question about what the stakeholders consider to be the causes of access. What they consider to be the causes of access, and some of them will include lack of accessibility planning, traffic jams, traditional rulers or council or corporate bodies. And then there's also a question of lack of maintenance culture, poor implementation of policies, lack of logistics, and poor transport coordination. And then there's also a question about informal settlements as one of the common themes as well. And we looked at the solutions that they have recommended to mitigate accessibility in the community. Some of the solutions include public education or public sensitization in both cities. There's also questions about BRT and bus stops. There's also a question about illegal street parking, and also adequate resource for walkways and road signs, and then also plan communities effectively. And also a question about proper periodic maintenance as a common solution between the two cities as well. Right. So the key takeaway that we got from our stakeholder engagement for these two cities, one is that we found that most of the stakeholders are very knowledgeable in terms of accessibility issues. And that is very encouraging in terms of coordinating activities between various stakeholders in the two cities. So this is not only for Tanzania alone, but it's also for Ghana, which it's very common in our stakeholder consultation. We also realized that some of the leading solutions that were that recur in both cities is effective planning, enforcement, and adequate funds for infrastructure development. Those were some of the three major suggestions or recommendations from the stakeholders. And there is also a high degree of identical views on transport access by the stakeholders. What we mean by this is that the views that we got from Dar es Salaam are very common to what we got from Ghana. Now, this gives us a good background in terms of technology transfer in terms of some of the challenges that we find in some of our cities, the solutions from our city can, in many ways, can be transferred. Of course, trying to also account for cultural and contextual background for these two cities. But what we are finding is that there is a very high commonality, which is a very good ground for technology transfer and exchange in this case. And finally, what we also want to emphasize here is that transport access should be something that should be continually monitored. And the monitoring should not be only in terms of traffic counts and an objective measurement of accessibility, but it should also include perceived accessibility as well in terms of how users are perceiving how they are using the transport infrastructure and the transport services that are being provided. With this, I will end here. Thank you very much.
Thank you so much, sir. Now, we have two more presentations before we go into discussions. The next presentation is on the causes and remedial measures of premature asphalt concrete pavement failure on federal roads of Ethiopia, which is going to be presented by Ehthiopia. She is a civil engineer at the Ethiopian Roads Administration. Ehthiopia is an experienced researcher with demonstrated history of working in civil industry, and she specializes in construction contract administration for highways, project estimation. She does that, and structural engineering and construction. Ladies and gentlemen, please welcome Ehthiopia to the podium.
Thank you very much. It's really an honor to present for you. As it has been introduced, my name is Ehthiopia. I'm a civil engineer by profession, and I specialized in construction technology and management. I'm from the Ethiopia Roads Administration. Today, I'm here to present you a study on the assessment on the causes and remedial measures of premature asphalt concrete pavement failure on federal roads of Ethiopia, which is a case study for 2 link roads and 2 trunk roads. So the contents of this presentation include general background, sampling criteria, result in discussion, as well as recommendations. So as a general background, we know that roads are very crucial for the economic development of any country. So in this country, our government has been spending billions of dollars, especially for the last 24 years, towards the road sector. And most of this investment is allocated to the federal roads. But the problem is some of this investment, or part of this investment, is being threatened by premature failure of the roads. So how do we define failure? There are various definitions, but one definition can be failure is an unacceptable difference between what is expected and what is actually realized, right? So that's failure. So how do we define a premature failure? According to different authors, it's a failure of a pavement way earlier than serving its design life. For example, if it fails within 6 months, according to Francis, it is said to be prematurely failed, or 2 months to a year, according to Cherif, or within 5 years after being open to traffic, it's supposed to be, it's considered as prematurely failed. And for our case, we considered 5 years, or we considered a road that fails before serving quarter of its design life as prematurely failed, sorry. So, is this really a problem? Is this really a problem? And if it is a problem, what is the extent of the problem? So the problem with premature failure is that it reduces the service life of roads, it adds to our maintenance costs, it causes us to make added reconstruction, it increases our vehicle operating cost, and it causes safety and comfort issues. And as you can see here, this is an issue in some parts of the country. So there have been a number of studies that have been done, case studies that have been done to address this problem. And the literature gap that we have identified is that, except for one paper, all of these papers didn't focus on premature failure, but failure in general. So we would like to fill this literature gap with our study. And the next gap that we want to fill is that most of these studies are usually case studies, which are based on laboratory study. And what we'd like to do is also do field studies, investigate the asphalt characteristics as well, and try to make a generic conclusion about the trends of premature failure in this country. So what is the objective of the study? In general, to identify the cause of premature asphalt concrete pavement failure and propose a remedial measure so that similar problems will not occur in the future. And the specific objectives include, to assess the modes of failures on the roads, to identify the causes for those failures, and to propose a remedial solution for the identified problems. Now let's talk about the scope. So this is the latest report of the RSDP. As you can see here, most of our construction happens on the trunk and link roads. So we are definitely studying trunk and link roads, and we are studying asphalt concrete roads. But however, we are not covering landslide-related failures or expressways, since they do have their own specialized scope. So now let's see the methodology. So, just like any research, we prepared the proposal, we did the literature review, we designed our research, and we did preliminary assessment on selected potential sample roads. And then once we are convinced that a given road has failed prematurely based on our site assessment, we did a detailed investigation, starting from desk study, which means collecting previous design documents, reports, condition surveys, and so on about the road, and doing a detailed desk study. Then we'll support that with a field study, a laboratory study, and we'll analyze the result and produce a report as well as a draft journal article. And the way we go about it is this, just to show you some of the laboratory tests that we have done. And we contrasted our findings with stipulations of the specification, the ERA manual specification. And also for the asphalt layer, we did a Marshall test and extraction test, and we contrasted it with provisions of the specification as well as the assumptions of the design. Now let's see the sampling criteria. So these are our researchers, Leknau and Tashome, as you will see them in the abstract. So initially, we were preparing to do our sampling based on a stratified random sampling, based on climate, and we were preparing to estimate the population size or sample size like this. But however, we find that it just didn't work. We have to make specific judgment about the road to find out, to visually first, to determine if it should be sampled. So for that reason, we change our sampling strategy into purposive sampling or non-probabilistic sampling. And in that, we considered a structural deformation or rutting. We selected tangent section of the road for sampling. We studied the good as well as the defective section. And we consider 300-meter stretch of the road as per our research procedures manual. So this is the first pilot study that we have done in the western part of our country. As you can see here, we did visual assessment, we analyzed everything. And this is the second sample that we have taken in the southern part of our country. The same here, beyond visual assessment, as you can see here, it has deteriorated very badly. And so we analyzed this in detail, and I will try to present you the findings of, a very brief overview of the findings of these roads. And just for your information, we are also currently trying to assess our third road at the eastern part of the country. And to date, we have also assessed a number of lots in 5 districts, and more than 12 lots have been visited. but only 3 of those have met our premature failure criteria. So this is a basic description of our first sample. It is located in Midwestern Ethiopia. It consists of 3 road segments, which means it was constructed by 3 contractors. The terrain is mostly rolling, and sometimes mountainous and escarpment sections are also observed. And as you can see here, the area is a little bit of cold with low temperature and high rainfall type of area, sometimes with also problematic soil underneath. And for our second sample, it's located in the southeastern part of the country. It contains 3 road segments, but for our case, we only selected one of the road segments. The terrain is mostly rolling, sometimes flat to escarpment. The altitude ranges from 1,600 to 2,800 meters, and based on the season, it can be very hot or it can be very rainy. So, as further description of the samples, functionally, we have got 1 link road and 2 trunk roads here. Here we got 1 link road. Both of them have a 7-meter carriageway. This has sealed shoulder. This has unsealed shoulder. Now, when we first did our condition survey, this is what we find. The first lot is in good condition, but it doesn't mean that it doesn't have some extreme rutting. This one is in fair condition. This was in fair condition. This was in fair condition. So. So fair is next to poor, so it's not the highest quality. And when you see the design traffic, as we know, traffic is one of the primary causes for pavement deterioration and pavement failure, right? So the design traffic was DS4, and the actual traffic that we find for the first sample was designed for T6. But in actual fact, it was carrying a traffic load of T8 and T7, which means it was carrying double or triple of the design assumption. So it is carrying a lot of load, right? So the second sample, the second road, it was sampled for, it was designed for T5, but however it was carrying a traffic load of T9. And this also means the axle load has increased 5 times. The actual axle load is 5 times compared to the design assumption. So when we try to see in depth what has increased or what has changed with the traffic data, this is what we have found. You know, for the first sample, the number of buses small buses has significantly increased, and the trailers have also substantially increased, but the volume of traffic was reasonably forecasted. It's just the traffic load, and the volume of traffic was good. But for this one, as you can see here, the volume of traffic exceeds the design assumption, and the axle load has also, you know, incredibly exceeded the design assumption. And these are the values that we have found for rating. In the right-hand side, there was extreme rating, especially for the outer wheel pass, as expected for all of the 3 lots. And for the inner wheel pass, we find extreme rating only for the second sample, which indicates a structural problem. Anyway, for the second sample, there is extreme rating in the inner wheel pass. So that's an indication of a structural problem. So these are the values that we have found for deflection. We use Benkelman beam for the lack of a better instrument, and these are the values that we have found. There is no restriction on the severity or indication on the severity of deflection according to IRA manual, but however, according to Tanzania manual, this is not a severe deflection. And this is also our DCP measurement on site, which is consistent with our CVR findings. And we also try to measure the thickness of the road compared to the designed assumption. This is the designed thickness. And for the first sample that we have found that all of the roads have the required thickness, except for the sub-base of the first lot and the asphalt road of the second lot. And this is design thickness for the second sample. As you can see here, it has significant problem with thickness for both the base course and the sub-base. So now let's see the laboratory result and discussion. This is a subgrade soil classification according to ASHTO. So when you try to see the first sample, it falls under the silty clay, fat silty clay and gravel, which means extreme silty clay and gravel road. So which means the first sample was reasonably good, the second sample was not a good subgrade material, and the third sample was a good subgrade material. And for the second sample, the material was good subgrade material. Actually, it was a capping layer. So this is just an overview of the results. You know, the red are the field criteria. So in the interest of time, we summarized the whole thing like this. So for the first lot, which is a link road, that the defect that we have found was for the subbase there is poor quality material, poor compaction and thickness issue. For the base course there is gradation problem and compaction problem. For the second lot, you know, except for the compaction of the subbase, we have found a material quality problem and compaction problem throughout the layers. For the third lot, there is a compaction problem for the subbase, and for the base course there is a poor quality material and poor compaction problem. And for the second sample, the subgrade material is good, it is a capping material, but the quality of material and the compaction and the thickness were problems for both the subbase and the base course. So we try to quantify, this is next to my last slide, so we try to quantify and prioritize which is the most probable cause of the failure, and we find that using poor quality material is the most probable cause of failure for the roads, and poor compaction is also a problem. And we also identified increase in traffic load as a primary problem for the failure of the roads, and for some sections, terrain and thickness of, or improper thickness of the pavement have also contributed. And as to the mode of failure, we find rutting and shoving as a predominant form of failure for sample 1, and rutting, fatting, longitudinal and edge cracks were considered for sample 2. We have already discussed this one. And the recommendations we have is that, you know, we should use good quality materials for our road construction. We should have strict supervision on site and quality assurance on site, and we should ensure that our site laboratories are reliable, and there needs to be proper compaction of layers. And for example, according to South Africa's most established researcher, Philip Page-Green, compaction is one of the least costliest, the cheapest ways to increase quality of our roads. So we need to work on compaction. And we also need to consider the percentage of heavy vehicle projection in our traffic forecast, and routine maintenance and axle load control should be given paramount attention. So these are the people that we would like to thank for the success of this project, all the regional management directors, road asset personnel and the respective districts, and the organizers of this workshop. Thank you very much.
Thank you so much. You know, when she was talking about road quality, I was just wondering about the Trans-African route that stretches all the way from Cairo all the way down to Cape Town. And I had the pleasure of hosting that event where former President Uhuru Kenyatta and my Prime Minister Dr. Abiy launching part of that road that stretches from Moyale all the way to Hawassa. And then between Hawassa and Zouai, there's a, I don't know, how many kilometers would it be, Engineer Jonas? About 50 kilometers? Only that is remaining for us to finish connecting Addis to Hawassa, to the port city of Mojo, then Hawassa, and then all the way to Zouai, and then, all the way to Moyale, and then it crosses through Kenya and down all the way to the last station. And it's just fascinating to me. Just a tiny unfinished part of this highway, the Trans-African route, is just so annoying because you'll be just loving driving on that fine road that stretches all the way from here to Moyale. And then, so, you know, I was just wondering about that. So I think Ethiopian Roads Administration is doing an amazing job, and this will continue throughout Africa. And we will someday be able to just get up and drive to Mombasa for vacation in just a day, you know, in fine roads. So thank you so much for that presentation once again, madam. Now, for this session, we have only one more presentation to go for, and then we will call upon our panel for discussion. Forgive me. Now, the last presentation is on deep excavation practices in Addis Ababa, which is going to be presented by La'alam Menuyellet. He is a graduate of Addis Ababa School of Civil and Environmental Engineering, and he is a PhD candidate at, again, Addis Ababa University, but an Institute of Technology. So please welcome La'alam to the podium for the last presentation. There he is. While he is coming, can you please get up and stretch a little bit, because, you know, we're a little tired, I think. Let's all stand up and move any way we want. Just make sure you don't punch somebody down. You know, they say sitting is the next killer, so stretching includes you too, sir. Stretch any way you want, shake hands, dance, move. All right. I hope you'll be awake enough for his presentation and the discussion. Did you break something?
Thank you. Thank you very much. Okay. Let me introduce myself again. My name is Lamlak Menuyellet. I am PhD candidate at Addis Ababa University Institute of Technology. I am a geotechnical practicing professional. I'm going to present to you deep excavation practice in Addis Ababa in collaboration with Dr. Engineer Henok Fikre. He's also from Addis Ababa, AIT. I'll try to make the presentation more condensed so that I will try to finish within 10 minutes. Okay. Okay. Thank you. I'll try to concentrate on the practice only in Addis Ababa, especially. In some parts, I will try to touch a practice that is done in the Omo River, but generally, I will concentrate the 4 basic practices that are being done in Addis. The first and the most common excavation support system in Addis Ababa that we usually encounter is soldier board pile walls. This kind of walls have been practiced for the last more than 10 years in Addis Ababa. We'll encounter more than 100 projects every year in Addis Ababa here, especially the right bottom corner picture depicts the one which is used in the headquarters of the Commercial Bank of Ethiopia. It may be constructed by using different modes of combinations, but the most practiced ones is the 3 ones, the cantilevered, the braced one, and the tie-packed anchor ones. Basically, for shallow excavations, we will use the cantilevered type wall, but the rest will be practiced when the depth of excavation is increased and other circumstances happen. Especially the tie-backed or the anchored type, it is somewhat time consuming, and also it needs a lot of activities. So we will use usually for deep excavation more than 8 or 9 meters, usually. The next common aspect of excavation support system in Addis is the second pile wall system. As to my experience, we have encountered such kind of construction twice. The one is the Ethiopian Red Cross Society headquarter building located near to the Commercial Bank of Ethiopia, which is under construction. I don't know whether you can see it or not. It is at the right bottom corner. In the middle, you can see a shallow depth excavation, which is done by using, similarly by using this technique, by including a corner brace, which is constructed for the Omo River bridge. These are the schematic pictures in order to show that. Basically, I like this type of construction because it's cost effective, but it's not that much commonly experienced, just like the previous one. Even they can be made from cement and soil mix columns, but the most common in our country, which is exercised, is by using primary and secondary, which are both concretes, but the one being reinforced and the other not reinforced. The third common, I don't know whether you will be familiar with this one, and I do always admire whether this is permitted to be constructed in city-wise, but we'll encounter a lot just like this. I've encountered 7 times this kind of construction. I don't know whether you can see it at the right bottom corner. It is similar to the first one type of construction, but in order to reduce the cost of reinforcement, they will replace the reinforcement by using woods, which basically are treated, but they are also used for shallow excavations. Usually they'll range for 9 meters of pile, so their excavation is limited within 6 meters. This type of constructions usually are common, and also you will encounter their failures also. The one you see at the right, it's the one that's constructed, but also it's failed. It has no analysis or design concept, simply it's based on tradition. The third common type, this one, it's also, I think it's patented. The owner of this construction company claims that he's patented. It's based on purely labors. As you can see, it's by using purely manually digging cantilever pile walls and replacing by them concretes, and it's by stages. It's very costly, it's very wide, but even in the downtown we encounter such kind of projects. Even at the backside of this there is a construction being undertaken by this one. This is a picture that is taken from that site. So these 4 types of deep excavation support systems are most common in Addis, the most common. The manually dig, the one that replaces the reinforcement by using the treated wood, and the second pile and the board piles types. So most of the time we encounter here and there failures, especially that are related to these deep excavations, especially nearby structures. They do commonly suffer from such kind of problems. So what was the common cause of failures for such kind of failures is we have tried to categorize them into 3 parts. The first comment that we encountered is design related issues. Under this there are a lot of issues: poor geotechnical investigation report, lacking in expertise, the academic learning process has also its role, the manner that professionals are also accredited, even the service the lack of esteem for the professions as evidenced by the salaries for this type of projects. And the basic one that we got from these categories, the GIGO, this garbage in, garbage out. Most of the time, those who are involved in such kind of design and analysis, they will try to use either limit equilibrium or finite element or finite difference PY curve analysis. So they simply give the softwares whatever it asks without knowing or with having minimal background. Then it will give them an analysis output. Then they will give it for reconstruction. Then there will be failure. In terms of this, basically the analysis and design commonly done is by using the limit equilibrium approach, which has a lot of input parameters that it needs that we see here, but we simply input it. So this GIGO strategy is one of the common reasons for such kind of deep excavation failures. The other, the finite element analysis issues that are related with the design for deep excavations, which type of model to use, 2D or 3D, what is the model extent that I should use, what are the model, the quantity model selection types, material characterization, element selection, 1 to 2D, 3D, which elements to use for which type of structures, what are these elements, truss, beam, plate elements, load combinations, SLS versus ULS, which one to use. Even the big challenge with this FEM is the post-processing, how to interpret it, how to use output, how to determine the actual shear and the moment, how to go to design, because they are most of the time analysis-based softwares, basically most of the times finite elements. The other from the design issue is the governmental authority's role. I have tried to see a lot of designs that are submitted to the governmental offices, but usually I can say they are submitted for the partial fulfillment of the other designs to be approved. They are not checked by the officials. They are simply seen as they will have a checklist. Have you submitted a deep excavation support system? Yes, checklist, right. They do not see just like the architectural and structural designs. So the government officials, one problem is this one. The other thing, most of the time when such kind of failures occur in Addis, I have tried to involve in so many juries. The problem is they are not penalized by the right government officials. So most of the time, if deep excavation failure occurs, it is fully the responsibility of the client. The shoring company or the deep excavation company will no longer come to that involvement even to search for a solution or a remedial action. The other that's related with consultants. Most of the time thinking that it is, I understand, a specialty. Most of the times they will not treat it, especially in terms of the contract administration, in terms of assigning the right supervision, in terms of assigning jury. Even they don't ask for guarantees also. So if something fails, since the client has no guarantee for such kind of constructions, it will be the burden of the client, not the contractor. So most of the time, consultants and such companies are weak in terms of this contractual, especially for these deep excavation support systems. The other poor construction, aside from design and analysis, during construction, this whole have a big role, especially the third item, the casing type. Most of the time, it's not given that much concern. So basically, we cannot see, because most of the excavations, they will go, the pile excavation or drilling, it may go to 20 meters. So in the middle of that, a lot of soil may collapse and without using casings, a lot of shorings have failed. I will show you a picture later. The other, the client interference. Clients by themselves. When you give them advice, clients, they have their own interest, especially after the construction is completed. They need to extend the depth of excavation. They will ask you, what will happen? I will take the risk. One more meter, please. I will take the risk. I will give you later, just like that. Then the whole area will be in a crisis. Next, the construction sequence. The clients usually just need the whole meter of excavation to be taken within 1 to 3 days. They don't want to keep the construction sequence. So clients specifically, they involve in this kind of faults. So what is the findings that we get? We have tried to search a lot of excavation failures in Addis Ababa, but due to their unwillingness to post it here, I'm going to present you only 2 of them. These 2, the left and the right one. This is the left one. As you can see, the neighboring structures have totally collapsed. And the problem of this one was they were advised to use the right construction, but the clients preferred $1 million to save, so they went for this type of construction, the one which replaces the reinforcement by using treated wood. There was a lot of dialogue, but the clients preferred this one because it was $1 million less. So what happened is, What happened is, as you can see, this catastrophic failure on the right and right side, a total of 4.5 million was totally lost at this moment. In order to save 1 million, the client lost more than 4.5 million. The one on the right side, the design was good, the construction was good, but what happened was that at the right corner, if you can see, during the construction, they didn't properly use the casing type that I showed you earlier. So after excavation, the total piles in the nearby structure collapsed, and there was a lateral deformation of nearly 78 centimeters, which is nearly a meter. So due to that, structural failure was there. So this project, me and my colleague, Dr. Engineer Henok, were involved for the mitigation action. And what surprised me this project was the client was not happy with the local contractors, even practicing engineers. So during the discussion, while we were presenting for him the remedial action, he was trying to negotiate with the neighboring guys in order to own the land. He was talking about 60 and 50 million per negotiation, but we are giving him somewhat 250,000 per remedial action. He didn't trust us at that moment, but after 2 months, I think, after 2 months of construction, we successfully completed this below 300,000 per. So this is around Bole. It has already reached the superstructure around, I think, 2nd floor something. Thank you very much. One more thing I want to stress as a conclusion, sorry for that. I've tried to list the problems, the design problems, the construction problems, the analysis problems, the governmental roles, the teaching learning process, everything. So what is the remedial action that we recommend for such kind of projects is that we do always tell to engineers that please, such kind of structures are involved with high USD dollar, especially for our country, it's too tough. So they are temporary structures. So let us try to be concerned in order to save some money. We should not spend, we should not give inappropriate sections, especially the associations. the Ethiopian Civil Association. It is helping us. We have another association that is already constructed, the Ethiopian Geotechnical Association. We are trying to do such kind of things as a seminar and a conference. So deep excavation should not be taken as easy. Thank you very much.
Thank you so much. Ladies and gentlemen, now we'll go to that quick discussion, which is going to be the last thing we're going to do for today. And my moderator for this session is Engineer Rafi Louay Beth Lazi. She is the President of Engineering Council of South Africa. It's my great honor to invite her to the podium to chair the session. And then all four presenters, please come up and assume your seats. And then we'll take some questions and suggestions and comments from the participants. And then we'll call it a day. Ma'am? Please go ahead. I was trying to save time by simply saying all four presenters.
Ladies and gentlemen, can we give them another round of applause, please? I do know it is the graveyard shift, but they did an excellent job this afternoon. You may take a seat. Yes, you may take a seat. We're missing one here. Just a short recap. You will recall we had Dr. Sahilu, who presented the water scarcity issues that we're facing. You spoke a bit more about how we need to have a look at our water and our plans as a community from a global perspective all the way to the community. You spoke about us having a roadmap in terms of our water. We have to have a register of drinking sources and location. We have to manage our water quality in the different areas that we are operating in. We have to look at how we as individual consumers self-regulate and understand the regulation of that water. You spoke about sanitation, transformation, the basin-based approaches that we can use, and we have to make sure that we do as much research as we possibly can. And Dr. Dumeda spoke about the transport aspect in terms of understanding the accessibility that we have in the transport space. It was very alarming that 72% of urban population live in informal urban communities, which means they've got limited access, Doctor. That's what you mentioned to us. And this, for me, tied very closely with Engineer Nigusi, who spoke about the quality of our roads and the probability of failures on our roads and what causes that. So if we're going to need more access, we're going to utilize more transport and different modes of transport, we need to cater for the traffic. And I think those two tied in very well, because when we do designs, we under-design not knowing the traffic that we're going to foreseeably have. It has an impact in premature failures on our roads. I think I took that from what you were presenting, Engineer Nigusi. And lastly, we spoke about the excavation and the different methods that can be used in the excavation. It's very important for us to understand the environment that we're operating in order for us to select the best mode and the best strategy for the excavation that we have. But equally, what I heard from Lemak is our designs are crucially important. Our relationship with our government and the role they play in the projects that we have. And as I saw the circulation of the pamphlet from FIDIC, it was coincidental that even the construction aspects plays a role in how we have our contracts and manage our contracts within the space of construction. So without even getting too detailed in the presentation that we've all heard, ladies and gentlemen, I would like to now put the floor back to yourselves to ask or comment any view that you might have to our panelists this afternoon. May I then hand it over to you, if there can be a show of hands to assist us, please?
All right, so you heard the moderator. Let's see some hands. It's the last discussion for the day. I want it to be energetic, so we have that energy when we go to the dinner reception at the Ministry of Defense. Where? Man, you're far back. Why is that, sir? There's plenty of seats here. Huh? Why are you standing so far back there? Making my life difficult.
Thank you. My name is Kenneth Adumaku Tutu. I'm from Ghana. I have a couple of questions for Engineer Niguzi. So during the forensic investigation, did your team sample asphalt, concrete materials, and did you perform any lab analysis on them, for example, to determine whether the bitumen content conform to the specifications? In the same vein, did you check the in-situ AC layer thicknesses to make sure that they conform to specification? My next question is, the sections that failed severely in rutting, I saw some figures, and the outer wheel path recorded very severe rutting. Did your team also document the shoulder and the drainage conditions within those sections to see if there could be factors contributing to the severe rutting? And my last question, out of curiosity, what grade of bitumen do you use here in Ethiopia? Thank you.
All right, do we have another one? Anyone else? Someone's phone's alarm is going off and doesn't seem to stop. Where is it? This is intentional. It's somewhere here, right? Yes, it's in the back. Okay, and the person is not there. And it's a lady's bag? It's a gentleman's bag. Is it yours? Oh, she's there. Oh, okay. Can I go inside, madam? You never know. You don't go into a woman's purse. Is she? Anyone with a question or suggestion, please? Yes, sir. Great. I'll come back to you, sir.
Thank you very much. My name is Dr. Engineer Ben Rafemoyo from Zimbabwe. I think mine is a follow-up question, if not a comment, again to Engineer Niguzi, sorry for the pronunciation, about the use of poor materials. I don't know whether the investigations went further to look at the actual reason why people would want to use substandard materials. Is it not a question of a good design, good spec, but people probably sharing the project funding into their own pockets, then leave very little for the project, and then you are forced to, buy substandard materials, which will be, the end result. Because sometimes we look at the symptoms and failing to deal with the actual causatives. I don't know whether corruption, which sometimes is rampant in project promotion and implementation, has also been looked at as one of the major reasons why people would go for substandard materials. Thank you.
Thank you very much, MC. My name is Engineer Rizwan Kadri. I'm the president of the Institution of Engineers Tanzania. My first question is directed to this excavation, deep excavations. I was wondering that, because this is based in Ethiopia, whereby I believe that you have soil which may be silty, clay, and undesirable, maybe black cotton soil as well. Did you ever encounter soil foundation interaction? Because you have a high-rise building here, I believe it's 48-story, and deep excavation may or may not be necessary because you can have a pile and route foundation, which could be easier, can go up to the depth where you need the first or second or third basement. So I was wondering if you have encountered that, and at the same time, Ethiopia is a seismic area whereby before you carry out any excavation, you need to make sure that you've done your thorough geotechnical investigation as well as give the necessary seismic details so that the design and excavation can be done properly. My second question goes to the lady on the failure of the wearing course rather than the pavement where you have mentioned. And you said that you have rutting problems mostly. If it's inner, it has to do with the structure failure. If it is outer, it's to do with something else. There are various other methods which the previous person who asked you questions as well stated that there are so many other tests you are supposed to carry out, which includes in situ CBR, plate loading test, as well as other tests which are to do with field dry densities. You only relied on Benkelman beam in order to get the deflection. So the rutting failure is mostly to do with the bitumen asphalt, the type you used, and maybe the Marshall mix was not done properly. So I think that whatever you presented is very good, but if you could add on this, it would have been fantastic. Thank you very much.
Thank you. Can we have 2 questions, one for water and one for transport? And then I'll hand over to the panelists to then answer all the questions.
Questions on water and transport? Anyone?
Any question from South Africa on transport? Yes, CEO of EXA.
Where is that? Okay, sorry, Pilar. It's me. Sorry.
Thank you. My name is Dr. Samula from Engineering Council, South Africa. So my question is a transportation question for Dr. Dumeda, and you talked about lack of access, and what I wanted to find out was what's the percentage of the access that was related to infrastructure versus the percentage that was related to services? Because if it's informal and some of the people are walking, sometimes the infrastructure might just be pedestrian walkways. So the non-motorized aspect of infrastructure for kids to be able to maybe walk to school might not be as capital intensive as building a road to a school and hospital. Thank you.
Thank you. One more question on water.
All right, seems we have one here.
Thank you.
Thank you. I would like to clearly have a description on the scarcity of water, especially on because the global water shortage is increasing from time to time because of the population increase in the global aspect, as well as the global water shortage due to pollution, and at the same time the shortage of water due to the shortage of individual per capita consumption. That has to be highlighted because of the future availability of water. And I want that to be described a bit in brief. Thank you.
Thank you very much.
No problem.
Thank you very much. We'll hand over to the panelists, starting with Engineer Ngusi. I think you've got the most questions.
Okay, thank you
very much for your valuable comments and useful input. So for the first question from Ghana, you asked me if we did a test on the asphalt. So yes, we did test on the asphalt, but it is limited to Marshall test and extraction test. We wanted to do a volumetric analysis, but we ran out of samples. So we got sample mix-up in the laboratory. So for this reason, we didn't do it for the first sample. But for the second road, we are still processing it in the laboratory. So the answer is yes, we did, but it is limited to extraction and Marshall test. So the other is a very good question, which is about the shoulder and drainage condition. As you have seen earlier, we have done a visual condition survey. That means we looked into the drainage structure and we found them to be adequate in all of the cases. They do have siltation, but they were adequate. And so that led us to the conclusion that from visual assessment, the problem is not mostly with the drainage, but with the strength of the material itself. And for the shoulder, the first one is sealed. Also, other studies also show that if your shoulder is sealed, your pavement can last longer. So, especially for the first three loads that we have seen, we don't think that shoulder is a major problem. But for the second one, the shoulder is not sealed, so it is susceptible to water ingression. And as we have seen, the material quality is also not very good. So for the third question, what type of asphalt grade do you use? Did I get the question right? Yes. So for example, for the first sample, they used 80 by 100, for example, for the first sample. And it depends on the temperature. You can use 60 by 70 and so on. It depends on the temperature of the area that you are working with. So all I can say is it depends on the site. And the second question is why do we use a substandard material? Why do we use a substandard material? For your surprise, in some cases, we found a CVR of 3 to 4% as a sub-base material. For a sub-base, at least a CVR of 30% or above is expected, and we found CVR of 3 or 4%. So it needs more assessment as to why this is happening. Is it a scarcity of material? Is it compromising quality? So it needs a little more investigation into that. But if I can tell you a good remedial measure that ERA has implemented, it has instituted project management offices on site. That means ERA personnel are on site, the contractor is on site, and the consultant is on site. So whenever there is a construction, the employer is nearby to inspect the quality of the roads. So the answer is it needs a little more investigation. So the other is also a useful comment from Tanzania. So why don't you use a field CVR, in-situ CVR and field density test using plate load testing? It's just that we don't have the plate loading test equipment yet, but we'll take this as an input. We'll look into that. And ERA is currently procuring equipment. So whenever we have the equipment and if it is justified according to the literature, we'll proceed with that. And thank you for your input. So, thank you.
Thank you. Thank you very much. We'll then move on to water before we come closer to the site. Yes?
Okay. Thank you, Engineer Valletta, for your good question. I would like to divide my responses into categories. The issue of water scarcity. Even if we do not have any external influence, usually it is measured meter cube per capita per year. So population growth only can reduce the available water. So whether it is negatively affected anthropogenic activities, as the population increases, the value decreases. That what is shown is, for example, from 1990 to 2025, the freshwater availability in Ethiopia actually has reduced almost by 50% because the population has increased more than twice. So that is one thing. The next point is anthropogenic activities, environmental degradation. So drying up of wells, river flow decrease is the result of unchecked activities. So due to the not planned activities, properly managed, no water protection areas, you could have drying of wells. We are experiencing that, for example, in Addis, in many cities in Ethiopia, wells, after functioning for a certain period of time, they are drying up. So that is one of the scarcity points. The third point is, okay, population increase, anthropogenic activity. Due to anthropogenic activity, the quantity of water might not decrease, but the quantity of fresh water decreases because of pollution. So the pollution, the increase in pollution actually decreases the availability of water. So this could be at local level, at city level, or at village level. The next point is actually, Engineer Valletta has not raised this, but I want to address, there are two types of scarcities: physical scarcity and economic scarcity. Economic scarcity is, even though the water is available, we are not exploiting it. Due to that, we have a problem in our water supply or other things. So the per capita freshwater availability can be affected due to population, due to anthropogenic activities, due to pollution, and due to economic or physical scarcity. That is what I can say.
Thank you very much. Before you hand over the mic, Doctor, you mentioned pollution as one of really an impediment. And at the moment, we're having a COP27 in Egypt. And I couldn't help but notice as well in your presentation, you spoke about how we need to start having plans for climate resilience. Would you like to expand a bit on that?
Okay, when we say, so we have to differentiate two things in the water supply and sanitation sector. The problem we have without climate change, non-climatic drivers. To be frank, the problem we have in the water supply and sanitation sector at the moment is mainly due to the non-climatic drivers. The climatic drivers are actually maybe the recurrence of drought, and others would make the water supply short. That is the climate effect. Or there will be flood. But the level we are in our water supply and sanitation sector would not push us to claim climate change for the problem we are in, because we have not yet developed it with the available resource. So climate resilience, actually there is one program in the Ministry of Water, Climate Resilience WASH, that means a water supply and sanitation initiative which is resilient even if there is a climate impact. So depending, for example, on very deep wells, which will not be affected due to some sort of shocks. That is what I can say.
Thank you very much. Thanks for clarifying that. We'll move on to Lemlak in terms of the excavations. Earlier in this year, South Africa experienced drought and flooding at the same time, because when the rains came, they did not really give us much of mercy. They really bucketed. And there are certain areas in the KZN, KwaZulu-Natal, that have experienced severe flooding, loss of life. And what we found is some of the design aspects and reinforcement of some of those houses that were built. And I think when you spoke about the pile walls that we use using treated woods, it really resonated with some of the designs that we saw back at home at KZN in terms of how people build on that various soil that you found and the type of reinforcement and excavation that they use. And that does not assist us when it comes to flooding, because it becomes a disastrous situation, just like we saw with that failed design that you showed. So when you then respond to some of these answers, I think it will be beneficial if you touch on how our designs could be augmented to accommodate for these climate adaptation situations that we are facing. Thank you. Over to you.
Okay. Thank you very much. The questions that raised regarding deep excavation is something related with soil structure interaction, pile draft, and seismic. It goes around there. Our presentation basically focuses on deep excavation support systems. It doesn't include the superstructure support systems or the foundation type selection or anything just like that, just simply deep excavation support. It's a temporary structure, except the one that I presented, if you remember, the second pile wall that is being exercised in one of the headquarters of the Ethiopian Red Cross. They were trying to make it a permanent structure, but finally it was near some structure, so it didn't successfully happen. But anyways, what we tried to present is temporary structures, and they are absolutely concerned with deep excavation supporters. They are not involved with deep foundation types. But regarding to pile drafts, the seismicity, the soil structure interaction, since deep excavations are temporary structures and they are planned for a maximum of 6 or 7 months, especially for this building sector, we don't consider seismic actions because they will give us the section to be very costly. So we don't expect at that moment seismic will happen within that 6 months because they are temporary structures, as I said. So basically we don't consider seismic actions in the design and analysis. But we do include these hydrostatic pressures, surcharges, cracks filled with water, something just like that, that we anticipate that may occur within 1 year, but no seismicity. But when it comes to deep foundation, just like pile drafters, yeah, we do consider seismicity, especially we do in mega projects, site-specific ground response analysis, we do non-linear time history analysis, even we do the traditional pseudostatic analysis, but they are concerned with deep foundations, not deep excavation support systems. Regarding soil foundation interaction, for this kind of deep excavation support systems, we use, especially for the characterization of the interaction between the piles and the soil, we do use, but it's not just like the deep foundation of the pile drafters. Whether you use finite element or limit equilibrium analysis, we do use, but it's not critical just like that of the pile drafters. As to the chair, I think the questions that you raised or the idea, it's I'm always offended when I see excavation support systems that have failed because they are temporary structures. Even on some sites, they have tried to have a damage on even on people. I don't think the main reason this deep excavation is rather than being a professional sector, now it's becoming just like business-oriented system. So the big responsibility lies to the universities and the governmental offices. As I said, if you see some of the governmental offices, they are only concerned whether you have submitted the deep excavation support system design. They will not check it because it's a lack of expertise, I understand that, but they will not give it even a half priority, just like that of the architectural and superstructural design. So the main role, I think it will be on governmental offices, associations, and such kind of conferences. Thank you very much.
Thank you very much for that. It seems that last statement regarding government intervention is almost similar to what Dr. Dumeda also mentioned in the transport resolution, when you spoke about public education, the BRT start and stop, and the fact that we need government intervention within the transport challenges that we're facing. So I think that's a common factor across board. We need to engage our government a lot more. But let's then hand over to Dr. Dumeda in terms of the question that was raised on the transport aspects.
All right, thank you very much for your question. So the question relates to, in terms of transport access, the proportion or the percentage that is attributable to transport infrastructure compared to services. Yes, at this stage for our work, what we have carried out is to look at the stakeholders who are actually involved in transport infrastructure, transport services provision, and the users. So we have engaged the stakeholders because we felt that for any intervention to happen, they are one of the key players within the system to be able to carry out any intervention. The next step for our work, which we have carried out but are yet to analyze the data, was that we went to the local residents and that took a questionnaire survey. Now, within that questionnaire survey, we have questions that are really targeted different transport modes. For instance, if you are walking, you are using a bicycle, or you're using a minibus or a tricycle. And then we will also look at how the transport infrastructure either inhibits or facilitates that access. And then also we have undertaken a travel time analysis. A travel time analysis to look at if you're using a car, a private car, or you're using a minibus to access a workplace. We have taken resident locations to, for instance, their workplace, or resident location to their health care, and then analyze all the travel time that is spent. And then the next stage for us to do is to compare the travel time that they reported in terms of accessing the workplace, and then the one that we will calculate based on the transport mode that they use to see how they compare. After that analysis, then we'll be able to associate the percentage that is attributable to the transport infrastructure and then to services. So it is a great question, but it's just that we have not completed our analysis to be able to come up with those results yet. Thank you.
Thank you very much. Ladies and gentlemen, are there maybe any other questions or comments before we then end and close this panel session? Yes, I see a question there in front.
Thank you very much. I'm Charles Adams from Ghana. I think I want to contribute to the response given by Dr. Domeda. Generally in our part of the world, we don't construct sidewalks or pedestrian walks, unless we are building a road. And even for roads, depending on the class of road. So you realize that for most commuters or people executing the last mile, they don't have, if they are walking, there may not be any sidewalk. Also, you realize that there is proliferation of all these three-wheelers because in many places the infrastructure is poor. So the public transport doesn't get there. And once it doesn't get there, they have to either walk to the main road before they can continue. So like what he said, the next stage of the work is actually to compare what we have observed with what they are saying so that we may be able to distinguish between how we may be able to prioritize pedestrian needs. Because as it is, we don't do that. We build a facility for vehicles. and then we do pedestrian facility as an afterthought. And we don't take the needs of pedestrians on board. But one of the things we want to emphasize in this study is that a lot of people walk, but we don't provide the facilities. I think that's one of the things we want to establish with is that if we want to improve accessibility to some of these areas, we need to invest also in pedestrian infrastructure and things like that.
Thank you very much, Professor Charles Adams. In the absence of any other, I see a hand right at the back there. Very interesting session that we're having.
Thank you. Please, I need a little bit of clarification from Engineer Nigusi. So regarding the asphalt material samples that your team collected from the field sessions, did I hear you say that you did Marshall testing on them? And if that's what you did, I'm curious. I want to know what you wanted to learn from that.
Engineer Nigusi.
We took the course and we did the stability and flow tests. And for the second lot, the stability criteria was not met. And for the one with a lower thickness. Did I answer your question?
This conversation perhaps needs to be taken offline. There might be more follow-up questions as I see. You want to help? Okay, let's take one last comment and then perhaps we will close. I do see that we are still on time.
Thank you. Basically, with the Marshall mix design, you can actually redesign the pavement which has been used. So the wearing course, the ingredients, the way they have been made, you simulate that in the laboratory by doing the design from the material sourced on site. I hope I've answered that.
Thank you very much. May I then request our panelists if there's anybody who would like to say a parting shot before we close the session? Doctor?
All right, thank you very much. I would also like to announce that our center in Kumasi in Ghana has a poster outside. So members can pass by the poster and we have information sessions there and we're happy to discuss with you some of our work that we've been doing. Thank you.
Okay. My part is just, I just like to thank the organizers and the presenters, even the chairs. Thank you very much.
Thank you very much. Thank you, Ms. Chair, for this wonderful, wonderful job that you have done. So the one information I would like to tell you is that the Ethiopian Roads Administration has a road research center, which the facility construction is recently almost completed. It is located at Kaliti. Currently, we are working to procure laboratory equipment for the facility. It has residence facilities, it has offices, and we are also trying to work with consultants for capacity building. So next time you come to Addis, please make sure you visit the Road Research Center. Thank you.
Okay, thank you. I just want to give a suggestion for this 8th African Week, because when I prepare for this presentation, what I have observed is there is really a limitation on Agenda 2063 in addressing the water supply and sanitation issues. So maybe one of the suggestions or recommendation of this gathering at the end of the 4 or 5 days workshop should be, presently we are depending on the SDGs 6 reports. We don't have our own African report on water supply and sanitation. So it should be taken like other sectors, like the energy, the transport and the like. So I recommend this for the organizers to pass to the African Union.
Thank you very much to our panelists. I think that suggestion has been recorded. If you will recall earlier, our FAO Madam President did say she looks forward to suggestions and recommendations that will come out from this week. So that is one suggestion that we will definitely take through to the organizers. And the chairperson of the Africa Engineering Week is sitting right there, Mr. Engineer Manoa, who has recorded that. Thank you very much. Ladies and gentlemen, thank you so much to yourselves as well for participating in this panel. It is the end of the day, the last session for the day, and I will then hand over to our MC as we then take our seats as the panelists to then close the session. Thank you very much once again.
Thank you also, my moderator, for such a great moderation work you've done. Now, ladies and gentlemen, this is the point where we come to the end of the session for today. We will be now heading out to the headquarters of the Ethiopian National Defense Forces, where we have our special dinner reception by His Excellency the Minister of Defense. All foreign delegates, please get on the buses, the shuttles, and we will take you straight to the National Defense Headquarters. And if your friends are already at their hotels, please inform them. We have already sent a group message on the WhatsApp group to be ready to be picked up from the hotels. But again, it also is good if you could inform them that we're going straight now to the National Defense Headquarters. Ethiopian friends, you'll have to be coming on your own. Sorry, we cannot really facilitate for everyone everything. ይሄንን የምናደርገው ያው እነሱ ተጨማሪ ገንዘብ ስለከፈሉ ከዛ አንፃር ነው 350 የአሜሪካውን የከፈሉት። ስለዚህ ከዛ አንፃር ነው አውቶቡስ ስለነሱ ያዘጋጀ ነው። እንደገና ያው የሀገርም ኢሜጅ ጉዳይ ስለሆነ ትንሽ መጠበቅ እንክብካቤ ስለሚያስፈልግ ከዛ አንፃር ነው። ይበቃናል። Are you sure? You sure? So, በጣም የምትቸገሩ ሰዎች ካላችሁ ግን በሸትሉ መሄድ ትችላላችሁ እያሉ ነው ኢንጂነር ዮናስ። ስለዚህ መከላከያ ሚኒስቴር በሳር ቤት በኩል ያለው መግቢያ በልደታ በኩል አይደለ? በልደታ በኩል ወርደን ያለው መግቢያ ነው የሚሆነው። እዛ ስም ዝርዝራችሁ ሊስት ይኖራል ማለት ነው። ስለዚህ ቀጥታ ነው የምንሄደው ጊዜው ስለማይበቃ። We're going to go straight to the National Defense Forces headquarters. Traffic is going to be a little high at this point, so we can't really hang around here to end West time. We have to really make it in time for the dinner. One more thing, tomorrow, to my left here, I'm sure you had a chance to look out the window. We have the dome, the very big, beautiful dome, where you have a virtual world experience of science, amazing experience. Tomorrow, everybody is going to get a chance to go inside and experience virtual world in that part of the museum. So don't miss it. And of course, His Excellency Engineer Takalomov, the Minister of Mines, will be here to speak to us. And Her Excellency Ferheot Yimer, CEO of the Ethio Telecom, also will be speaking tomorrow morning with us. So please don't miss tomorrow's session. With this, I thank you all. Have a good evening. I will see you at the party.